Hello friends, in this video we will solve problem based on general transformation. So here is the problem. So determine 3 into 3 homogeneous transformation matrix. So we have to find the homogeneous transformation matrix, which is also known as resultant transformation or total transformation. To transform square ABCD into another square A dash, B dash, C dash, D dash. So we have to transform a square ABCD and we have to transform this square into another square, that is A dash, B dash, C dash, D dash. So the figure is also given, so which means that this is that square A, B, C, D. So initial position, initial figure, this is the initial figure with, and final figure I am naming it by dash, so it will become A dash, B dash, C dash and D dash. So this is the final figure, which means that we have to convert this square into the outer square. So what all transformation we have to do for transforming the inner square into outer square, we have to calculate, and we have to also find the total transformation matrix. And some data has been given, that is side of square is 2 units and coordinate of point, so this coordinate has been given as 20, 10. So coordinate of A is given as 20, 10. So the square is away from this origin, which means that this is the square A, B, C, D, and it is to be transformed into another square. So final figure I am naming it by dash, so A dash, B dash, C dash, D dash. So this is the original figure, and we have to convert this figure into this figure, so I will name it as final figure. So you can see initially the square was of this form, and we have to convert this square into this form, that is of final form. So for converting this figure into this figure, we require the series of transformations. So you can see the square has been rotated and the size of the square is somewhat bigger of final figure with respect to original figure. So two transformations are there. One is rotation, because we have to rotate. Here initially point A is here, and here in final figure the point A has been rotated, so rotation transformation has been done, and you can see the size of the figure is increased, so you can say that scaling has been done. So now we'll start the transformation, but before starting, the initial figure is away from the center, and the rotation and scaling is done with respect to origin. So for that, or for performing rotation and scaling transformation, we have to bring this original figure to origin, and then we can perform the corresponding transformation. So for that, I have to bring this initial figure to origin. So for finding out initial figure, I have to mark down the origin of the square. So this is the origin of square, and we already know the side of the square is 2 units. this side is also 2. So now I have to bring this point O to origin, and we can perform this series of transformation, and we can easily convert this figure into this final figure. So for that I will plot this initial figure onto the graph so that I can get the coordinates of O. So first I will plot the initial figure. The coordinates of A is 20, 10. So 20, 10, which means that the point comes somewhere here. So I will name it as A. And since the sides of square is 2, so B will be 22. So this is the B point. So I will join. And C also, ABC, since the side is 2, so it will become 10 plus 2, 12. So I got this point as C and this point as D. So this is the initial figure. So based on the coordinates and side of square, I plotted the square onto the graph. Now I have to calculate the origin. So origin means center of the square. So center of the square, which means that this side is 2. So center so this is that origin. So you can see the coordinates of O is 21 and 11. So half of 2 is 1. So 20 plus 1 is 21. And similarly 10 plus 1, 11. So the coordinate of O, that is origin of the square, is 21, 11. So now we got the coordinates of origin. So now we will perform the first transformation, that is translation. So first translation, that is I will translate this point to this origin, which means that I am moving in this direction and this direction, which means that 21 units in x direction. Since I am moving in negative direction, so I will take tx as minus 21, and since in y direction I am moving with 11 units, but I am moving in downward direction, so ty will be minus 11. So translating point O to origin. So for translation we require two things, that is tx and ty. Translation along x direction, so it is minus 21, and translation along y direction, it is minus 11. So the standard translation matrix is given by T equal to 1 0 0 0 1 0 tx ty 1. So now I will put the value of tx and ty so that I can get the corresponding matrices for translation. So it comes out to be 1 0 0 0 1 0 minus 21 minus 11 1. So this is the matrices for translation. So after performing this translation transformation, the figure comes out to be now this O has attained the origin position. So this is A, B, C, D. So now we successfully brought the center of the square to origin. Now we can easily perform rotation and scaling transformation. So from the final figure, it seems that this A has been rotated with some angle, which means that we will perform rotation transformation, and the direction of rotation is in this direction, which means that it is anti-clockwise rotation. So initially A is here. So after performing rotation, A will come somewhere here. So I will name it as A dash. So the angle with which it will be rotated, it is theta, is 45 degree. Means for attaining this A along this line, it has to cover 45 degree of rotation, and the direction of rotation is anti-clockwise, which means that sign convention is positive. So now we will do rotation transformation. That is second transformation is rotation, that is rotate A by 45 degree anti-clockwise. So we have to rotate A, that is point A, by 45 degree anti-clockwise. So theta is 45 degree. It is positive as it is anti-clockwise rotation. So now I will write down the standard rotation matrix as cos theta, sin theta 0, minus sin theta, cos theta 0, 0, 0, 1. So this is the standard matrices for rotation transformation. Now I will replace the value of theta as 45 degree. So the matrix comes out to be 0.707, 0.707, 0, minus 0.707, 0.707, 0, 0, 0, 1. So this is the matrices for rotation transformation. So after performing this rotation transformation, the figure will become so I will name it by dash. So A dash, B dash, C dash, D dash. So we rotated the square which were required in the problem. So initially A was here. So after rotation transformation, A comes out to be here. Now you can see the final figure is somewhat bigger than initial figure, which means that we have to perform scaling transformation. So next transformation we will do, that is scaling. So third is scaling. So for scaling we will require the value of Sx and Sy. That is Sx is scaling along x direction and Sy is scaling along y direction. So you can see initial figure this is A, B, C, D. So if I will join the diagonal and I know this side of the square, so by Pythagoras theorem I can calculate the diagonal AC as 2 root 2, and the final figure is of this form. This is A dash, B dash, C dash, D dash. So from the graph, so I will draw the final figure. So the final figure I am naming it by dash. So A dash, B dash, C dash, D dash. So we calculated this diagonal as 2 root 2 because I know this side is 2 and this side is 2. So we can say this side is 2 root 2, this side is also 2 root 2. Since it is a square, all sides are equal. So I can say this diagonal is also 2 root 2. So this also comes out to be 2 root 2. So now all the sides of the outer square is 2 root 2. So this is 2 root 2, this is 2 root 2, this is also 2 root 2, and this one is also 2 root 2. So I can calculate Sx equal to Sy as, so you can see here AB, that is the formula for scaling is scaling, that is change in x direction upon original change in x direction. So the formula for Sx equal to Sy, new figure in x direction upon original figure in x direction. Similarly, since it is a square, Sx and Sy will be the same, so we can write for Sy also. So new figure in x direction, so new figure in x direction, so here initially it is AB, and here AB is 2, and here A dash B dash is 2 root 2. So Sx and Sy comes out to be root 2. So we calculated the Sx and Sy. So now we will write the standard matrices for scaling. So S equal to Sx 0 0 0 Sy 0 0 0 1. So now I will put the value of Sx and Sy as root 2. So the matrices comes out to be root 2 0 0 0 root 2 0 0 0 1. So this is the matrices for scaling. So now we successfully scaled the final figure, that is final square, whose size is somewhat bigger than the initial figure. So after performing the scaling transformation, the figure comes out to be A dash, B dash, C dash, D dash. So we successfully converted a square this square into this square. So but you can see the square is away from origin, and we brought the initial square to origin for performing various transformations so that I can convert this square into this square, which means that I have to place the transform square back to its original position, which means that I have to translate the O, that is I have to do back translation, that is translate O back to its original position. So last transformation I have to do in this problem is translation, because figure initially is away from the coordinate axis. So last transformation is translation. So I will write translate point O back to its original position. So initially we have done translation so that we can perform scaling and rotation, as scaling and rotation is always done with respect to origin. For that case we brought the initial figure to the origin. So same thing we are doing, we are back translating. So for translation we will require two things, that is tx and ty. So the coordinate for O is 21, 1. So after perform scaling, the figure is here. So the center O is here. So I have to place back to its original position, which means that I have to go in positive direction, that is in right direction, right hand side direction, and I have to go in upward direction, which means that both are positives. So positive translations to be done. So we have to move 21 units in x direction and 11 units in y direction. So tx is 21 and ty is 11. So standard matrix for translation is given as 1 0 0 0 1 0 tx ty 1. So now I will put the value for tx and ty as 21 and 11. So 1 0 0 0 1 0 21 11 1. So this is the matrices for back translation. So now we will calculate the total transformation, which is also known as resultant transformation, because we have to find the homogeneous transformation matrix. So homogeneous transformation matrix, that is TR. So first we have done translation, then we rotated, then we scaled, and lastly we performed back translation. So I will multiply all the matrices, then the corresponding TR comes out to be 1 1 0 minus 1 1 0 11 minus 21 1. So this is the total transformation, which is also known as homogeneous transformation, which we was to calculate. Thank you.